Okay, so this is going to be another example arc length problem, but instead of being a function of y, this one is a function of x. And we can see that it's not a function of y because it doesn't pass the vertical line test, so to speak, for functions of y, but it does pass a horizontal line test. So we can actually find the arc length of this function. Let's say we wanted to find it from y equals 0 to y equals 3, which is somewhere around here. We'll say it's here. So we'll go from 0 to 3. So that means that a is going to be 0 and b is going to be 3 for our closed interval AB. So we remember our formula for arc length would be the length is equal to the integral from a to b. And because this is a function of y, I'll write this in terms of y. 1 plus f prime of y squared dy. That's a y. Okay, so now let's say we want to work this out. Well, we set, what's our function? Well, this is our function, so let's find its derivative. F prime of y is going to be equal to, well, you bring down this 3, this is just a power rule thing, so you have y squared, because it cancels out this 3, and then you have plus 1/4 times, this is y to the negative 1, so this would be a minus 1, times y to the minus 2. So we have f prime of y is equal to y squared minus 1/4 y to the minus 2. And I like to write my, all variables in the numerator fractions with negative exponents if necessary, because that makes integrating a bit easier. So we're going to come on down here, and I'm going to have a bit more room over here. So the length is equal to the integral from 0 to 3 of the square root 1 plus y squared minus 1/4 y to the minus 2 squared. This will just keep coming out. dy. Did I forget my dy up here? No. Good. So the length is equal to, and I'm now going to distribute this because we can't integrate right now. 1 plus y to the 4th and then you get minus, well, if we multiply this term and this term together and multiply it by 2, we have 2 times negative 1/4, so that would be negative 1/2. And y squared times y to the negative 2, so that would be just a y to a 0, or just multiply by 1. Now we have plus 1/16 y to the minus 4 dy. Yeah, that's an awful y. There we go. So dy. And now we can combine like terms. The length is equal to the integral from 0 to 3 square root of y to the 4th plus 1/16 y to the minus 4th y to the minus 4th plus 1/2. And I get the plus 1/2 from simply adding the negative 1/2 to the positive 1. dy. Okay, and continue on out. Now remember, we're trying to get a perfect square in here, or get a u sub. And we can't do a u sub, so we're going to end up doing a perfect square. So what can we square to get something here? Well, I can't see anything easy off the top of my head. So what I'm going to do is back up, and I'm actually going to write this in as a fraction. So what I'm going to do is get to solve the common denominator. So that would be 16y to the 8th plus 1 plus 8y to the 4th all over 16y to the 4th. Now, how did I know to do that? Well, you can see that currently the most complex denominator down here is 16 times y to the 4th. So I saw that that's also a perfect square. So I can continue this because I'm really taking the square root of the top and the bottom here. L is going to be equal to integral from 0 to 3 of the square root of, and this is a perfect square, we can see that quite simply, 4y to the 4th yeah, 4y to the 4th plus 1 squared over 4y squared. I took the square root at the bottom here, dy. So I continue. The length is equal to the integral from 0 to 3 of 4y to the 4th. I just take the square root of this. I'm going to divide it up into two fractions. Over 4y squared plus 1 over 4y squared dy. So the length is, and this will be the last time I write an integral, we'll actually integrate it in the next step. So y squared plus 1/4 y to the minus 2 dy. So integrating, we have L is equal to y cubed over 3 plus 1/4 times y to the minus 1 over minus 1, evaluated from 0 to 3. The length is going to be equal to, we plug in 3, we get 9, because it's just going to be 3 cubed, or 3 squared, plus 1/4 times 1 over negative 3. So that would be equal to 9 minus 1/12, which I have here. Did I say we're going to go from 0 to 3 or 1 to 3? 0 to 3. So this would be the answer to the problem, which I can simplify on my calculator here. So that would be 107/12.